Good evening, everyone. In the last class is discussion about kinematic equations. There are three different equations of three different kinematic equations. That is also called the motion along a straight lines. It is classified into three different equations. The first equation is v is equal to v naught plus at. The second equation is s is equal to v naught t plus 1 by 2 at square, and the third equation is v square is equal to v naught square plus 2s. These are the three equations is called the kinematic equations. The kinematic equations, that is also called the motion along a straight line, motion along a plane, motion along a plane. That is the first equation is v is equal to v naught plus at. How to derive in this equation? That is, first to draw the velocity versus time graph. The velocity time versus the velocity along a x direction and the time along, that is the velocity along y direction, the time along x direction. That is the all physical quantities are taken along y direction. O is a initial position. O is called initial position of the particle. When a body A, the particle A is traveling certain distances, that is the position of the final position of the particle is, that is C. That is, draw the final distance of the particle. It is taken as, that is the point B, C and D is called final velocity V, and the V naught is called initial velocity. V naught is called initial velocity. Draw the tangent. The line AB is called tangent line, where theta is the angle between the tangent line and time axis. That is the explanation of the given graph. First, what is the meaning of VT graph? V versus T. The VT graph. The VT graph means the V is a velocity. That means the velocity along y direction, the time along x direction, that is called VT graph. VT graph means the velocity along y direction, the time along x direction, that is called VT graph. First, consider the body moving with the initial velocity is v naught. O is the initial position. The initial velocity is v naught. The body is subjected uniform acceleration is small a. Small a is the acceleration. What's the meaning of acceleration? This tangent line is called acceleration, or the rate of change of velocity is called acceleration. When a body is subjected to uniform acceleration is, that is small a, and its velocity changes from, when a velocity is changes from initial velocity to final velocity. V naught is the initial velocity, V is called final velocity. The time taken is small t, the time interval is small t in second. According to the VT graph of a body, the velocity time versus the velocity time versus graph is shown in this diagram. From the definition of the slope of the VT graph is, that is called acceleration. The definition of acceleration. What is the acceleration? The acceleration means the rate of change of velocity is called acceleration, and the one more definition is the acceleration is defined as the slope of a line. The slope of a line. The slope of a line is called what? Acceleration. The line name is, that is AB is a tangent line. That is a 45 degree. 45 degree. The slope of a acceleration. The slope of a line is called acceleration, or the acceleration A is equal to the slope of the line AB. That is a tangent line. The theta, where theta is the angle between, that is tangent line and AC line. The AC must be is equal to OD line. That is a time axis, along a time axis, that is tan theta. Angle is tan theta. What is the definition of tan theta? In mathematical trigonometric ratio, that tan theta is defined as opposite by hypotenuse side. Opposite by hypotenuse side. That is, the theta is the angle. The theta is the angle. The side, the opposite side is called opposite line. The upper line is called hypotenuse side. The lower side is called adjacent side. By using the definition of that tan theta is defined as opposite by hypotenuse. The opposite is BC. This line is called BC, opposite side. The hypotenuse side is, that is a AB. AB is the opposite hypotenuse side. Therefore, the BC can be written as the total distance is the total final velocity is, that is the BD minus CD. The BC line can be written as BD minus CD, that is called BC line divided by AB, that is the AB, that is a theta. That is by using the definition is wrong. The tan theta, that is a tan theta is opposite by adjacent side, not hypotenuse. The tan theta is defined as opposite by adjacent. That is, the BC is the opposite side. The adjacent side is called AC. The adjacent side is called AC, that is called AC. Therefore, BC can be written as BD minus CD. AC, that is, the AC line is parallel to OD line, that is OD. The BD, that is the AC, must be equal to OD, or the acceleration A is equal to, that is the BD, that is the BD line is A, the BD line is A, that is the final velocity. It is the CD is parallel to what? AO line. The AO distance is initial velocity. Therefore, the BD is the final velocity minus CD must be equal to AO, that is the initial velocity, divided by, that is OD. What is the distance? That is the time. The OD distance is called time. Cross multiply, V minus V naught is equal to A into T is, that is called VAT, or V is equal to, that is the minus negative is shifted that side, positive velocity plus 18. This is the first kinematic equation. That is where the V is called final velocity, the V naught is called initial velocity, A is called acceleration, small t is time interval in second. Small t is called time interval in second. That is the kinematic first equation. And second one is derive the S is equal to V naught t plus 1 by 2 AT square. Derive the second equation, the displacement equation, V naught t plus 1 by 2 VT square. Same diagram and same explanation. First, plot a graph velocity versus time. Plot a graph of velocity along y direction, time along x direction, that is O is a initial position. When a body is travels, the particle A is travels certain distance, that point is called C, and the total, when I draw the slope of the velocity versus time, join the line, that is B is the slope of the tangent, and BD is perpendicular to OD line. It is a theta is the angle between slope of the line and time axis. The initial velocity is taken as v naught. The final velocity is taken as, that is, v. That is the explanation, that is the graph of a velocity versus time graph. As it is same explanation, consider the body is moving with a initial velocity is v naught, that the body is projected to a uniform acceleration is small a. Small a is the uniform acceleration, and the velocity is changes from v naught to v. That means initial velocity to final velocity in a time interval is small t. Time interval is small t. S. What is the S? S be the distance traveled during the time. The S is a distance traveled during the time. The velocity time graph of a body as shown in the diagram. This is the velocity versus time graph. The distance traveled by the body in time small t in seconds. The distance traveled by the body in small t seconds. That is, the distance is equal to, that is distance, S is a distance is equal to area under the velocity graph. What is the area? Area of area under the velocity time graph. S is equal to, what is the area of this graph? Area of the figure, the area of the trapezoid. That is the area of a trapezoid. The area of a trapezoid means displacement is equal to, that is area, that is a 1 by 2 length into breadth. That is the length, that is the parallel lines, sum of the parallel lines into, that is the length, into the parallel length is into perpendicular lines. That is the area of a trapezoid. That is the distance moved by the, or the distance covered by the, traveled by the body in small t seconds is given by S is equal to area under the VT graph, or S is equal to the area of a trapezoid. The area means, that is a half into length into breadth. Length, that is a BD is the length and O is the length. That is a BD and AO. That is the sum of the lines, the sum of the parallel lines. That is the breadth. Length means, that is a OD. It is perpendicular line into perpendicular line, or S is equal to 1 by 2 the sum of the parallel lines, that is a BD plus AO, sum of the parallel lines into perpendicular line, OD. Or the S is equal to 1 by 2 BD. BD is called final velocity, and AO is called initial velocity v naught into OD is a along a x direction. It is a x direction means the time along the small t is the x direction, the time along x direction, or the displacement S is equal to, that is 1 by 2 by using a first kinematic equation V. Find out the value of V. The kinematic first equation of a motion. First equation of a motion. What is the first equation? But V is equal to V naught plus AT. Substitute this value in above equation. That is called equation number 1. That is called equation number 2. The equation 2 in 1 we get. The V value is That means the final velocity is, substitute equation number 1 we get. Therefore, the displacement 1 by 2 v value is, that is the v naught plus at plus v naught bracket close into small t, or 1 by 2 v naught plus v naught is 2 v naught plus at into small t, multiply integer and small t in each term, that is a small t, that is 1 by 2 2 v naught 2 v naught small t plus 1 by 2 a t into t is t square, 2 get cancelled. Finally, that is s is equal to 2 get cancelled, v naught t plus, that is 1 by 2 a t square. That is the second, that is equation number 3 is called second kinematic equation. That is, S is a displacement under the VT graph. V naught is called, that is the initial velocity, and A is called acceleration. Small t is the time interval in second. Time interval in second. That is the kinematic second equation. Once again, the second equation is S is equal to V naught t plus 1 by 2 et square. First, draw the velocity versus time graph. The velocity along y direction, the time along x direction. Consider the body A. Draw the body A moving with the initial velocity is v naught. The body is projected to a uniform acceleration is small a. The velocity is changes from v naught to v. That means initial velocity to final velocity. Initial velocity to final velocity. And the small time interval is, that is small t. Okay, now next, as shown in the velocity versus time graph. And s is called what? The distance. S is called, that is a distance moved by the particle. The S is called distance traveled during the time interval, as shown in the diagram. The distance traveled under the VT graph is given by, the distance traveled by under the VT graph is, that is S is equal to area of the trapezoid. That is, what is the area of the trapezoid? That is O A B C D. That is a trapezoid. O A B C D. The area of a trapezoid O A B C D is given by, area means, that is a 1 by 2 length into breadth. The area means 1 by 2 length into breadth. That is length, that is the breadth, 1 by 2 as it is. Breadth means, that is a BD line and AC line is the breadth of the given trapezoid. It is the BD and AO, sum of the parallel lines. It is the sum of the parallel lines into, it is two lines is perpendicular to what is the length, that is the OD is the length of the trapezoid. That is the area of the trapezoid OABCD is given by 1 by 2 sum of the parallel lines and perpendicular line. The sum of the parallel line means BD plus AO line. It is two lines are perpendicular to OD line. It is a perpendicular line. Therefore, S is equal to 1 by 2. The BD is, that is the final distance, and the AO is called initial distance. The OD is the time axis, time, that is called equation number 1. What is the V value? By using a kinematic first equation, motion along a straight line, the first equation is, that is V is equal to V naught plus AT. That is the V value. This value is substitute the above equation. S is equal to 1 by 2. that is the v value is v naught plus 80 plus v naught into t. 1 by 2 v naught plus v naught is 2 v naught plus 80 small t. Simplify number and small t. 1 by 2 2 v naught into t plus 1 by 2 1 by 2 a t into t is t square. 2 get cancelled, that is v naught t plus 1 by 2 a t square. Finally we'll get the second equation is, that is s is equal to the displacement under the VT graph is s is equal to v naught t plus 1 by 2 a t square, where s is a displacement, v naught is the initial velocity, small t is the time is the acceleration. This is the concept of the kinematic second equation. And finally one more equation is there, it is derived to next class, continue to next class. Okay, thank you.